Okay, so let's go through some stuff. As I said, I'll give you the normals, but you have to know where things line up. So. This equation. On the respiratory side. You have these two compounds, water and CO2. You're exhaling it right now. That's balancing out your pH, getting rid of that. It travels through the bloodstream as a neutral, meaning no ionic charge, otherwise it would do things. It's a neutral compound called carbonic acid. And there's an enzyme that breaks it up into water and carbon dioxide. Does anybody know what that's called? Carbonic anhydrase. Takes out the water. The other side, this is the metabolic side. You have H plus, more H pluses, acidotic. That's what acid base is. It's the amount of H plus that you have, or less, and your buffer, your primary buffer, bicarb. And notice how the equation can go either way. So for instance, if you give somebody bicarb, it'll drive the equation this way. Carbonic acid, which then with carbonic anhydrase will become this, water, carbon dioxide. But if they can't breathe at all, let's say they're in respiratory distress, it goes right back the other way and nothing happens and they stay acidotic. So those equations can go either way depending on what's accumulated. So giving bicarb isn't always the answer if you can't breathe it out. It'll go right back in the other direction. With respiratory issues, the pH and the CO2 go in opposite directions. As CO2 goes up, pH goes down. As the CO2 goes down, the pH goes up. Opposite directions. That's what we're looking for. On the metabolic side of things, they go in the same direction. And where's the other batteries? Oh, we're only need one. See what I didn't wait for. No, don't exhaust it enough. Okay, let's see that one. Nice. Those are. Oh, oh well,
Same Phil.
what?
How are you gonna learn?
I don't know, I'm gonna have to go to the.
Batteries. What about the board? They first like go.
One more try. Sorry. Okay. So on the metabolic side, things go in the same direction. Bicarb is your buffer. As it goes down, there's nothing to eat up the H pluses. You become more acidic. As bicarb goes up, now you're eating up more than you need of H pluses. Person becomes alkaline. So there's really only 4 conditions that we're concerned about. Alkalosis, either metabolic with bicarb up, or respiratory with CO2 down in the opposite direction. Metabolic respiratory alkalosis, metabolic respiratory. Acidosis, metabolic CO2 down, bicarb down, excuse me. On the respiratory side, CO2 up, pH down, opposite direction. So these are the four conditions we're kind of concerned about. Now, the APG trying to tell us what we've got comes at 7.435 to 7.45. So guess what you think is first on your APG? pH. Then 35 to 45, guess what's next? CO2. 60 to 100,
Those two.
that is the partial arterial pressure of oxygen at sea level. It is not the same thing as the pulse oximetry. Pulse oximetry is percentage of hemoglobin molecules that have an O2 attached to them. How many receptor sites on a hemoglobin molecule? 4. So if you only have 3 of them, you're at 75%. If you've got them all saturated up to 95% or more, you're normal. That's not what this is. This is the partial arterial of oxygen at sea level, which is 20%, 19 to 20% of that 760 torr, which is how they get 60 to 100. Because most of this is nitrogen. A little bit of some other stuff, so it's about 19% oxygen. Guess what 22 to 26 is?
Bicarb.
Your normal bicarb level. You also get bicarb with a BMP. They should be the same number. If there's a discrepancy, which one is more accurate?
BMP.
Oh, I got some of a little bit of both.
BMP.
It's actually the BMP.
Go.
The BMP, if you have a discrepancy, go with the BMP. They should be the same number, most of the time they are. And finally, this is called base excess. Base excess is the amount of this ion, OH negative. Negative. The more of that you have around, since it's negative, it eats up positive ions like hydrogen to become water. I'll get to that in a second. So the base excess is not really, although some of your instructors like it, used predominantly to decide whether or not it's an acid-base problem. It's really only used to confirm a metabolic acidosis. Because if you have a metabolic acidosis or alkalosis, if there's a metabolic problem, then you'll have fewer or too many hydrogen ions. If you have too little hydrogen ions, that means more OHs are floating around with nobody to marry. Then your base excess goes up. If you have too many hydrogen ions on the metabolic side, then it eats up and marries off all your OHs, and you have too few. And that's called a decreased negative base excess. So really, the only time we use base excess is when we're trying to confirm a metabolic side problem. -3 to +3 is normal. If I start seeing +4, +5, that means nothing is marrying off the OHs. Which means there's too few what? H pluses. They're metabolically alkalotic. If I start seeing -4, -5, there aren't any OHs around. They're being eaten up. What eats up OHs? It's a negative ion. I need a positive ion to marry it off. Guess what I have? H pluses. There are too many around, and they're metabolically acidic. That's how base excess works. I don't use it on respiratory problem. It's only confirmatory on the metabolic side. And the reason you have H pluses around, I need to just kind of go a little, you remember high school math? Water is a covalent molecule, very stable. Very little bit of it disassociates in a liquid solution like your body. How much? About 0.00000001 millimole. Incredibly small. I don't like using numbers like that, so I use scientific notation. That number is actually 10 to the negative 7. Right? Which can also be written, if you put it in the denominator, 1 over 10 to the 7. Let's take away the negative, put it in the denominator. But the interesting thing about numbers in the denominator, the bigger the number gets in the denominator, the smaller the overall number gets. 1,000,000 is greater than 2. But if you put it in the denominator, a 1,000,000 is much smaller than 1/2. So when it's in the denominator, the larger the number, the smaller the overall number. So if you remember logs, 10 to the 7 is actually written as the log of that number, base 10, and just make the 7 the answer. So the log of 0.00001 base 10 equals 7 in the denominator, which means everything we're talking about is this ion, H plus. So remember, in the denominator, the larger the number, the smaller the average overall number. So if 7 is right down the middle, neutral, if I make it an 8, which is a larger number, it's in the denominator. What ion is actually decreasing? H plus. You actually have fewer H pluses. Everything is based on H pluses. And if I make the number less, but it's in the denominator, you're actually having increased H pluses. Therefore, a 1 is less than 14, but it's in the denominator. A 1 means you have a lot of H pluses. And a 14 means you have very few H pluses, because it's in the denominator. That's how we get pH. Because it's in the denominator, the smaller number means the more H pluses. So 1 is incredibly acidotic, and a 14 is incredibly alkaline. Yes. Too much bicarb, this negative ion, HO3 will eat up this positive ion and take it out of circulation. And if it's not in circulation because it's married off, then the person will have the right amount of bicarb, but because you added some, but not as many H pluses. Remember what I said about giving it to somebody with potassium, hyperkalemia. There should be 1 or 2 H pluses inside the cell. If you give somebody bicarb, does that bicarb know not to eat them up? So you could inadvertently cause, giving bicarb, a metabolic alkalosis, which is very hard to treat. So there's certain parameters in a living patient to give bicarb. Does anybody remember the parameters? They're dead is one of them. What if they're alive? No.
pH has to be pH less than
pH less than
7.2.
7.1. That's acidotic. Meaning you're not worried about a metabolic alkalosis. There's way too many H pluses around in the first place. And the other one is less than 15. You should intervene. So there's the partial arterial pressure of oxygen. There's your bicarb. There's your base excess. That's how an APG comes. And it comes all from this. And the normal 7, little on the alkalotic side, 7.35, 7.45. And does the body like pH out of whack? No, it does not like it either side. Once it's out of whack, you've got problems. And that's what we have to deal with in surgery. People have these problems. So normal pH, H plus balance, but it's in the denominator. So the higher the number down there, the smaller the overall number, the amount of H plus molecule. Dissociation of water, log, inverse log, we talked about it. It's about hydrogen ion concentration. The ratio of bicarb. So if you have too many bicarb, you'll be metabolically, that's the metabolic side, alkalotic. It'll eat up your circulating H pluses. Too few bicarb molecules, you have those free radical H pluses, your pH will go down. Same as the bicarb, same direction. On the metabolic side, you become metabolically alkaline. If it's about accumulation of CO2, opposite directions. On the respiratory side, CO2 goes up, pH goes down. Respiratory side, CO2 goes down, pH goes up. Metabolic side, bicarb goes down, pH goes down. Metabolic side, bicarb goes up, pH goes up. So not as complicated as it looks. That's basically it. All right, have a nice day. So this equation again, but notice I tried to make this arrows in both directions. It'll go either way depending on what's accumulated. It's not a one directional thing. Bicarb control kidneys produced in the liver. So the liver makes it, the kidneys can pee out more or less. CO2, that's the accumulation of acid on the respiratory side, controlled by the lungs. So all this comes into play in acid-base balance. The liver making bicarb, the kidneys urinating out, making more uric acid, and the lungs breathing out CO2, all to keep you in balance. Well, those are the chemoreceptors in the brain, but the organs that are doing the work, yeoman's work, are the lungs, the kidneys, the liver. The brain is the computer, but they're not doing the heavy lifting. And those receptors, it's in the brain stem actually, and in the back of the carotids, or the back of the throat, the chemoreceptors. So pH maintenance, the heavy lifting part of it, not the computer part. Buffer system, produced by the the liver, pee out more or less by the kidneys. The respiratory system, breathing, CO2. You can hyperventilate, you can hypoventilate, control that. And the kidneys, making uric acid, more or less gets out acid in that system. So my question to you is, if you start to get out of whack, even a little bit, which do you think system jumps into effect first? Respiratory. Respiratory. Any other respiratories? A lot of respiratories. Anybody say kidneys? Got no kidneys. Anybody say buffer system? Buffer system people are right. Within milliseconds, before I can even finish this sentence, if I start becoming acidotic, my liver will shut the computer, the brain will tell my liver to stop making bicarb and tell my kidneys to pee out more. Milliseconds. The respiratory system blowing off CO2 takes a few minutes to catch up to the buffer system. And the most efficient system is actually the kidneys. They will really balance you out by either withholding or peeing out bicarb, withholding or peeing out uric acid. But what's the problem with the kidneys? 12 to 24 hours. So even though it's the most efficient, it's the least timely. The buffer system is instantaneous. It already happened before I could finish that sentence. Buffer system, milliseconds. Liver, stop making bicarb, kidneys pee it out. Respiratory system, a few minutes to really start having an impact. The kidneys, about 12 to 24 hours. It is the most efficient, but it's also the most delayed of the three of those systems doing the heavy lifting. So, acid base, tachypneas, bradypneas, anxiety, post-surgery. Didn't worry, they're anxious about surgery. It happens more often than you think. Pain. We're supposed to manage their pain. One of the reasons is we don't want them splinting themselves. If they just had abdominal surgery, you know what happens when they breathe? They just had abdominal surgery. You know what you use abdominal rectus muscles for? Everything. Try slicing up your abdominus rectus. You can't move in bed. You can't do that early morning cough that clears your throat. If you sneeze, it's like someone shot you. A cough, it's really painful. So guess what people do when something really, really hurts? They don't do it. It's called splinting. And as they splint themselves, they stop breathing deep. Those sacs, those balloons at the bottom of the lungs don't inflate. They collapse. And guess what happens? They develop what? Atelectasis. And now they accumulate carbon dioxide. And now when that accumulates, they go into a respiratory acidosis because the PA didn't treat their pain. Pain can actually do exactly the opposite. Pain hurts. Can it make them upset? They start breathing like this. Now their CO2 is out there. Guess what they just put themselves into? A respiratory alkalosis, which shows you that proper pain management of your post-surgical patients is life preserving. It's critical. So pain, head injuries, Cushing's reflex. Does anybody know what Cushing's reflex is? They had a stroke, they have a subdural. They'll get hypertension with a really wide pulse pressure, 180 over 100. Their heart rate, because of that hypertension, starts to drop. They'll become slightly bradycardic, and they'll develop a central neurogenic tachypnea, because CO2 is a cerebrovascular vasodilator. And if they're bleeding in there, they naturally start being tachypneic to blow off CO2, so it shrinks it. Who here is EMS? We used to do that with head injury back in the day. We'd hyperventilate them. We had to stop because we were doing it so good, we were making the brain ischemic, which is just as bad. So now, unless they have signs like herniation, blown pupil, they're starting to look like they're dying, we still hyperventilate them to blow off CO2. It's part of Cushing's central neurogenic tachypnea. And does anybody know what that weird breathing pattern you see sometimes with someone in a bad head injury? James Stokes. Periods of apnea to try and revascularize the brain, then periods of tachypnea to blow off what chemical? CO2. So, alkali, again, acid on the respiratory side, SSCO2. Alkalosis, blowing off CO2, opposite direction of the pH. Less or more CO2 on the respiratory side indicates the acidosis. They go in opposite directions. Rep CO2 accumulates, pH drops, and vice versa. On the metabolic side, who determines the acidosis? Alkalosis. It's a different chemical. Bicarb, but they go in the same direction. Bicarb down, pH down, bicarb up, pH up. Metabolic side. All right? Less or more bicarb, metabolic side, acidosis or alkalosis. And is there such a thing as compensation? So what happens if there's a metabolic acidosis? What will the body do?
Lower the CO2.
It will. It'll hyperventilate. If we don't do it, it'll try to do it itself. They could become tachypneic. Someone with a diabetic ketoacidosis is in what respiratory pattern? Lose miles, deep and fast. What if they have a respiratory acidosis? Within milliseconds, what will the body do? It'll tell the kidneys, the liver, do what? Stop making bicarb and tell the kidneys pee out more. Yeah, tell the kidneys, get rid of the bicarb.
I want to tell them to also.
If they're in a respiratory acid alkalosis. If they're in a respiratory acidosis, they'll tell the liver do what? Make more bicarb and pee out less. What is the compensation
if they're in a metabolic alkalosis?
Well,
Hypoventilation, I got one hypoventilation.
yeah,
Yes, yes. Doesn't happen. There is no actual, you can hyperventilate them. Back in the day, if someone was hyperventilating, we'd put a big bag over their face. We did it. The body won't do that to itself. Because what would happen if you were in a metabolic alkalosis and you hypoventilated only took one breath a minute for like half an hour? You'd be what in 20 seconds? Unconscious and dead. The body won't kill itself. So guess what? This is why it's harder to treat. There is no internal, not extra, it's us. There is no internal compensation for a respiratory, a metabolic alkalosis. The body will not suffocate itself. It would die before it would have an impact. 2 to 3 minutes of breathing 1 a minute, you will be dead. You only have 4 to 6 minutes to begin with that oxygen. If you see someone breathing 1 or 2 a minute, you know what that's called? It's a word for it. Starts with an A. What? It's called agonal respirations. Agonal meaning not enough to sustain life. You can have agonal ventricular rhythms. You can have agonal respirations. They're there, they're just not life sustaining. So important, because if you have somebody and you're not sure, is this a respiratory acidosis with a really good alkaline sided compensation? Or does this patient have a metabolic alkalosis with a really good respiratory compensation, which is it? It has to be the respiratory acidosis, because will the body compensate itself for a metabolic alkalosis by hypoventilation? No, you've just got an answer for one of the questions on the exam. Buffers is the proteins and phosphates, intracellular buffers. The principal extracellular buffer, which if you remember, it's about half in the cell and half outside the cells, is bicarb. That's the number one. Chloride is its backup. Carbonic acid system. We talked about that. Arrows in the same direction. Respiratory side, CO2, but it can go backwards if there's no way to blow it off. Carbonic acid with carbonic anhydrase, bicarb, metabolic side, and the H plus ion. More or less. More in the system, pH down. Less in the system, pH up, because it's in the denominator with carbonic anhydrase. So figuring out when you get a patient with a BMP and an ABG is finding out what problem your post-surgical patient has and dealing with it before and after the surgery. So you try to figure out the most obvious problem. Now, there are formulas. I'm going to warn you, they're a little complicated. They have numbers like 0.08 and then and 7. I don't like those numbers. But if you like formulas, I would put them on the exam. There is a metabolic acidosis formula. So if you have somebody with a pH of 7.26, they are what? Fine. You want to know if it's metabolic? You plug it into the formula. If the formula works, it's a metabolic acidosis. If the formula fails, what acidosis is it? There's only 2. If it's not metabolic, it's respiratory. And there's a metabolic alkalosis formula. I'm going to show you also, I call it Phil's intuition. I calculated another way. And I'm going to show you that you both get to the same answer. You're welcome to use either formula on the exam. It will still all be the correct answer. I use mine because I want to know, and this always seems to give students a problem. Will the body attempt compensation for, let's say, a respiratory acidosis? It will. The question is, did it work? You're a baseball player. You go up to the plate. Are you gonna try and hit the ball? Yeah. Okay. Do you always hit the ball?
No.
Sometimes you swing and you miss. That's the body too. The body can attempt compensation, but it didn't do anything. It didn't mean it didn't try. It just didn't help. That's called an uncompensated, maybe a respiratory acidosis. Could you get a single? You didn't score a run, but at least you're on base. That's called a partially compensated, let's say, respiratory acidosis. Can you hit a home run? Fully compensated respiratory acidosis. And how do you know? Use my formula and the pH. If my formula matches the pH, nothing happened. If it's better, but not all the way home, it's partially compensated. If it's all the way home, it's a home run, it's fully compensated. The only one that doesn't apply to is metabolic alkalosis. Why? The body won't suffocate itself. It will not hypoventilate itself. It will die. So ID, the most obvious disorder based on the ABG's pH. Acidosis, alkalosis, or neither. Either they don't have a problem or they're compensating fully. That could happen. If you breathe fast enough, you could compensate for a very minor metabolic acidosis. That happens. I know you won't compensate for a metabolic alkalosis. Apply the formulas if you like. I give them to you. You just pop in the numbers. Figure it out. That's how you answer the questions on my exam. Anion gap. Now I gotta explain the anion gap. Does anybody know what this skeleton is?
BMP.
The BMP, sodium, potassium, CO2, which is really bicarb, chloride. These are what? Anions or cations? Cations. These are what? Anions. There's a difference between them. If you take these two, add them up, take these two and add them up, and subtract these from these, there's some left. A distance. Does anybody know what the normal distance for the anion gap is? That's way too small.
5 to 12.
Nope.
Yeah.
Now, hold on, it's 9 to 16. The reason I'm putting that and saying, hold on, is because I just lied to you a little bit. And I'm gonna have to tell you why. This is the precise formula to fill out the anion gap. Add the cations together, add the anions together, and subtract them. But it's not the conventional formula. You remember when I talked about balancing calcium with albumin? There's a more precise formula with 0.08 in front of it, but the conventional formula skips that. Conventionally, when we're practicing, everybody skips the potassium because it doesn't account for much. It's only 3.5 to 5.2. So the conventional formula, the formula I'm going to be using on my exam, you don't take this into consideration. So the anion gap is Na by itself minus the anions. Bicarb, HCO3 negative plus Cl negative. Put those two together, subtract it from sodium. That's the conventional formula. The reason I said, yeah, if I lied to you, is this 9 to 16 actually reflects the anion gap for the conventional formula. If you use the precise formula ever out there in the world, and you decide to use potassium in the equation, the actual number changes of what the normal range is. It's a different range. But for my exam, I'm using the conventional formula, which means this is your range. On the anatomy table, what does the anion gap reflect? Anybody? So that distance. Yeah, what is it? I mean, like, can you dissect it?
No, like stuff. It's
If
there.
lost like my card or if there's like. If it's a black acidosis, so.
You're not telling me anything I don't know, unfortunately. That's what a metabolic acidosis is, what's the byproduct? It means absolutely nothing. It's not on the table, it's not like a lab value like potassium. I know what 3.0 is, it's not on low potassium ions. There is no anion gap physically. All it is that if you do say, I know my diagnosis. This pH is down 7.1, the bicarb is low, it's 18. The CO2 is low also because they're trying to do what to this metabolic acidosis? By doing what to their breathing? The CO2 is low, they're breathing off carbon dioxide, so CO2 is 20. They're trying to compensate for a metabolic acidosis. Now, you've established this patient has a metabolic acidosis. I agree with you. The question is why? So, the anion gap is really nothing more than Criminal Minds. It's a TV show where they try to figure out who the unsub is. Who's doing all this killing? Well, the anion gap isn't a lab value. It isn't a number. It isn't something in you. It just gives you an indication to the culprit, the villain. Why are they in a metabolic acidosis? Because if you know why, now you can figure out your treatment. If you come up with a why and you find out they lit some antifreeze, I know what to do. There are two types, as you said. There's a type of acidosis, metabolic acidosis, that makes the gap bigger. Instead of being 22, 9 to 16, it's 18, it's 20. That's a positive gap, metabolic acidosis. And there's a mnemonic for it. Does anybody know the mnemonic? Mud pilot. There's one that doesn't change the anion gap. They're still metabolically acidotic, but because they lose both a cation and an anion in equal proportions, it never changes the gap, but yet they're acidotic because they've lost their bicarb. Anybody know what a very prominent non-anion gap causing villain from a metabolic acidosis is? Where you lose both bicarb, which makes you acidotic metabolically, but they also lose a cation like potassium, so the overall gap stays the same. And I bet you everybody in this class has had it at least one time or another in their lifetime. Diarrhea. You lose potassium and bicarb in your poop. The gap stays the same, but because your bicarb goes down, you become metabolically acidotic, but a normal gap. That's why we calculate the gap in metabolic alkalosis, to find the villain, so we can treat the villain. It's not a lab, it's not anything in you. It just tells you where to look. Criminal Minds, crime scene investigation. So pH imbalance, acidosis, respiratory and metabolic, alkalosis, respiratory and metabolic. Those are your four conditions. Systemic compensation. I know in a metabolic acidosis, you might breathe faster. I know what will happen in a respiratory acidosis. Your body will stop peeing out bicarb and your liver will make more. And in a respiratory alkalosis, you'll tell your liver to shut up and pee out more instead of retaining. What about a metabolic alkalosis? What will it tell the body? No compensation. Body will not suffocate itself. No hypoventilation. You'd be dead. And what's the point of that? So 4 possibilities, just to simplify things. respiratory acidosis. The CO2 will be dramatically up. The bicarb may be go up a little, because what is the body attempting to do? Compensate. Was it successful? We don't know. Could it be an attempt but not successful?
Yeah.
Uncompensated. There's the attempt. I see it didn't work. Could it be partially?
Yeah.
Could it be fully?
All people.
How do we know?
Yeah.
Look at the pH. If the pH is back to 7.4, it worked. If the pH is still at 7.2, it didn't work. That's where my intuition comes into play. Respiratory alkalosis. The CO2 goes down. The bicarb may be down a little bit as well. The body's attempting to, liver, stop making it. Kidneys pee out more. Metabolic acid. This is where the bicarb is more dramatic. It's down. The pH is down, same direction. CO2 may be down a little bit as well, because the body's blowing it off in an attempt to do what? For a metabolic acidosis. Can it blow off some acid on this side of this equation? Too little bicarb means too much H plus, metabolic acidosis. How can I do something on this side? Blow off what is the acid on this side? CO2. What kind of respiration pattern? DKA. Who's miles? That's what they're doing. It's an attempted compensation. Metabolic acidosis. So the CO2 may be down as well in an attempt to compensate for that drop in bicarb, leaving behind a lot of H pluses. Metabolic alkalosis, the bicarb is dramatically up. Too much of it. Most of this is our fault, by the way. CO2 actually remains normal. Will the body say, don't breathe and let the CO2 collect in your body to compensate? No, your body will not start accumulating CO2. Has anybody ever held their breath for a long time? It hurts. Your body won't do that on its own. First of all, you go unconscious. You really can't suffocate yourself either. If you hold your breath long enough, if you can get past the headache and the pain of not breathing, you will go unconscious and start breathing. Uncompensated. The body swung, but missed. Strike one. It attempted. You might see the attempt. A respiration at 20 in the metabolic acidosis, and the pH might still be in the base. It missed. Partially. Strike, it hit the ball, but only a single. They're on base, but they didn't score a run yet. Again, that's partially compensated. And then compensated home run. The CO2 and the bicarb may be completely out of whack. One might be down, one might be up. Yet, guess what the pH is? In the normal range, because the compensation worked. So the bicarb is 16. The CO2 is 20. They have a metabolic acidosis, 7.4, fully compensated respiratory side for the metabolic acidosis. The pH is back in its normal range. Any of those are possible. So it can be an attempt, swing and a miss, an attempt, single, attempt, home run. And it's based on the pH. Compensation again. If there's a respiratory acidosis, the body will tell the liver to make more bicarb. Kidneys pee out less, so it may go up a little bit. Dramatic side is the respiratory accumulation of CO2. If there's a respiratory alkalosis, CO2 is dropping, the pH is going up. Body will tell the liver, so you'll see a drop in bicarb, more in the urine. Body's attempting to compensate. I don't know if it was successful, but you have to look at the pH for that. I just know there's the attempt. If there's a metabolic acidosis, the body will attempt to blow off CO2 on the respiratory side. It might go down. The pH, though, went down, same direction. If it were a respiratory problem, which direction did the pH and CO2 go? Same or opposite? Opposite. So if I see the CO2 down and the pH down, is it a respiratory problem? Now I look over and the bicarb is 10. It's a what acidosis? Look at the pH. Could it be uncompensated, even though there's an attempt? Yeah, the pH could be 7.24. Could it be 7.32? Maybe it's partially compensated. Can it be a 7.4? Fully compensated. Look at the pH. And there's my intuition will tell you whether it's partial, or fully compensated. What if there's a metabolic alkalosis? The pH is up, the bicarb is up. Will the body start accumulating carbon dioxide to try and compensate? We'll do it. There is your ABG, and there are the normals. pH 7.35 to 7.45. Partial arterial pressure of carbon dioxide at sea level, 35 to 45. Partial pressure, that percentage, like pulse oximetry. This is arterial pressure at sea level, 60 to 100, the oxygen. 22 to 26 is the bicarb of the ABG. Not as accurate as the BMP, but they should be the same anyway. And base excess, OH negative. Negative, more acidotic for a metabolic acidosis alkalosis problem. Positive, more, fewer H pluses. So 7.4. What is that as far as pH? 50. It's high. So whatever this is, it's fully 80 on the oxygen, 29. High. So, question, is this too high on the bicarb? I took this right off the exam. Is this a metabolic alkalosis, too much bicarb with a fully compensated respiratory side? Or is it a respiratory acidosis with a fully compensated metabolic side? Which one? Why couldn't it be the other one? Why couldn't this be a metabolic alkalosis, too much bicarb with a respiratory fully accepted respiratory compensation? The body
I don't know.
won't do that. Will the respiratory side be able to accumulate CO2 in the presence of a metabolic alkalosis? So that's out. What's left standing? It's a what? It's a respiratory acidosis with a fully compensated metabolic side. Does everybody agree with that? It can't be the other one. If you only have two options and one it can't be, it has to be the other one. And since their pH is 7.4, it's what compensated? On, partial, or fully? Fully. This is, when you get this page on your exam, this is a fully compensated respiratory acidosis with a fully compensated metabolic side. If you pick the other one, shame on you. I'm giving you a question.
Thank you.
So ID the most obvious disorder. Look for the pH. Is it acidotic or alkalotic? Look at the bicarb and the CO2. See what's high, low, or normal. I know if the pH is down and the CO2 is up, it's a respiratory issue. If they're in the same direction, but the bicarb is also in the same direction, it's a metabolic issue. If both are normal, pick one. As a matter of fact, when I do these, I always start with the patients in respiratory. And then I either prove myself right or wrong and go to metabolic. I just think it's easy to start at respiratory and say it's not working, metabolic. Because there's only two types of acidosis. If it's not respiratory, it's, and vice versa. Normals, gotta know them. There's your normal blood pH. Partial arterial pressure of CO2 at sea level. I give them to you, you gotta know where they line up on the A and G though. Bicarb. Chloride is on your BMP. That's a secondary bump. It's not on an ABG. Bicarb's 1, chloride's 2, which is important because you need that backup. If I put in an NG2 and I suck out everything in your stomach, what am I sucking out besides food and bile? What's down there that digests your foods? Hydrochloric acid. If the body expects it to be there, it's already compensating for the fact that it's in your stomach, so that your overall pH is 7.4. It knows it's there. What if I suck it all out? The body's expecting it to be there and it's not. What could I inadvertently, iatrogenically put them into? What kind of alkalosis? Metabolic alkalosis. And will the body attempt to compensate by hypoventilating? No. That's why it's hard to treat alkalosis. The body can't even help you out. Bicarb is number 1, chloride is number 2. So you have to think about that. Hypochloric acidosis. How do we get this? You can also give excess sodium. So I tell you, don't load them up with sodium. Sodium floating around the bloodstream is Na positive. It likes to bind to what thing and turn it into salt. And you know what happens to your chloride levels? They drop. So putting in too much normal saline could put someone into a hypochloric acidosis. Not right away, but eventually. So it's only resuscitative. It's not a good maintenance food. Basic chart. This is a chart that will help you study and make your diagnosis. If the pH is down, all right, the CO2 is down a little bit, but the dramatic one is on the bicarb level is down in the same direction as the pH. pH down is what? Alkalosis or acidosis. Bicarb is dramatically down. Well, the PCO2 might be down a little bit as well, because the body's attempting to do what? Compensate metabolic acidosis. pH up, it's a what? Alkalosis. The PCO2 is probably neutral. Didn't change, but the bicarb is dramatically up. It's a what alkalosis? Why isn't the CO2 going up? Body won't do that. What? Because I didn't make the slide. Cancel out that arrow. The body won't do that. pH down, CO2 dramatically up in opposite directions. What do they have? What? Respiratory acidosis. The bicarb might be up a little bit, attempting what? I don't know if it worked, but it's there. Respiratory acidosis. And then the other side, pH up, PCO2 down, it's a respiratory alkalosis. The bicarb may be down a little bit as well in an attempt to compensate respiratory alkalosis. This is a good side to study. Everything you need to know in 9 box, 10, 12 box. So acid base, key comments. The only ways acid to assist from is too much CO2 on the respiratory side, too little bicarb on the metabolic side. Alkalotic, same problem. Too little bicarb on the metabolic side, too little CO2 on the respiratory side. And you gotta remember the body poops out potassium and bicarb. So diarrhea could make you hypokalemic, we talked about that, and also a non-anion gap, because nothing changes on the gap, metabolic acidosis. That's why we check the anion gap, just to find the villain. So, all right, so let's let's take a 10-minute break and come back at 4:10, and we'll do some formulas. Yeah, because you lost me at five.
Double check though.
I got it.
Sure.
Sure, but, Dr. Emmett, I hear was closing his office.
Yeah.
And he needed some more time on Friday, so I got this. I got those.
Like, we might have to.
Yeah, but I gotta give you a little bit of a break. You know, everything I got, then it hits the Russian days.
That's 3 hours kitchen. So you're gonna have to.
I need something that's established for us.
I'm scared.
So they back to me.
I don't think it's Friday.
It's a 10 Whatever. Don't worry, you have the same amount of lecturing on Friday, it's an hour less at me, and an hour more of classes.
Oh, you must.
Yeah, school's fun.
Yeah. I know Shane's so big.
Yes.
I know.
I think it's because,
You learn every single topic ever. System.
I feel like if we.
Like, I'll tell you, PDFs.
Yeah.
I don't really like it, just because, yeah, that's a lot.
All these places alive.
I really feel like you tell a lot of like heavy nerve, like his brain is like. That's what I actually first time he like.
Yeah.
What are you doing? Something you're doing. I mean, they found it. Yes, it's the first time, it's like.
That was your basement, or still coming here?
Yeah, that's it. That was the teachers. That's a lot.
You know, like I feel like you're fine, but then if I'm asked a question, I don't know what class it's coming from.
I don't know.
I don't know.
Students are in PowerPoint slide.
Oh, you do?
Yeah.
Where about her kids? I should really do this. You the last question. I was like, it was just.
What were the other questions?
Oh, did he have like the burritos?
No, it wasn't.
It was the affirmative.
Oh, yeah.
The affirmative.
Yeah, like that's down.
And then they got a.
Organizations, yeah.
That's what Travis said, like.
I know. Me too.
And then he'd be like, which one is the best one?
Yeah.
But they have to drive.
Oh. Yeah, that's my master.
Yeah. It's fine, but her, the next two are. So one day off, she will better on her jobs.
It's so much better. Yeah, I accept it.
I'm just.
Yeah. That's like really. No, I think whoever knows what you allowed to get. Oh, shit.
I'm just really asking that, so there's a name.
That's not what I'm here.
You did.
Yeah. So I put the temple Saturday for this month, for six, everybody was trying to say. Nothing thoroughly. I was like, no, I don't know. They had like.
Durham was a Thursday. And I was like cramming Durham for the sour beers.
Maybe I should stop. Yeah, you're bad. Medicine.
I liked,
I think it's like typed it up, maybe.
like while I was here, I felt more fun now. So do I.
I just thought they were.
I like the way you asked questions, it like makes sense. It was just so frustrating.
Yeah, but I think like, did I typed it up, just like, can spend the time.
I typed it up too.
I know, I had like. Like, I was like just typing it, like, I was like.
I wish I knew.
Yeah, like, I was at, that was. I needed that.
Wait, that's actually.
You know, like, Jen,
So now, what is that?
Yeah. Like my dad.
But that'll, but it averages it.
First one.
My first one, I looked at this hour and 11 minutes, and the second one was 2 hours. And that's one, it was 2 hours. I come down.
I'm gonna watch one tomorrow, but not.
But I'm gonna, like, go off and edit, I will broadcast, to do it.
Bunch of voice tracks.
Oh, yeah.
PDF clips.
I
Because I didn't watch familiar. I've never watched it, I was like, oh.
Yeah, I didn't want.
Sorry.
It's a really fun, I get it, but like.
Yeah.
Yeah, I watched it.
Because it is.
I did not study for.
But I like it. The first one, and I'm gonna go down too. And then, here goes.
So, wait. Failed assist. See what was this.
Oh my god, look at the tree.
Oh,
Look at the tree.
the one that wanted
Tree.
Also,
Everywhere else going on.
Yeah.
They're like, yeah, you guys.
Yeah, I made a little extra for you guys. I made a watch for it. The different.
Yeah.
Well, I guess he's got nine.
Oh, yeah. So what's the worst? And then even though it's school bath. But I tried to.
Wait, what do you think? If I'm on this. Yeah, I was trying to check where you are.
Yeah.
For long.
Right.
That's like you love persistent. I help because I. I was like, so.
The breast thing is like.
Oh, I said that. I feel I'm dash smart. I was like, you can do over here.
Well, other ones didn't make sense. They were like too long.
Didn't make sense.
Oh, yeah.
Yeah, that makes sense. But I'm like, that's the way that- But for dash smart.
Also for net. Can you look at the breast?
No longer than.
Breast disorders, 29, breast cancer.
Forgot.
That is not long.
Yeah, but I feel like it's like. I don't know, yeah, before the information you need to.
Like that.
I mean, we have to.
I like that. That question.
Wait, are you looking for?
I had. And then.
Yeah, I think. The radio thing.
If they have that interesting little.
So, yeah. Still here, you know, parents are like, you put it up, I want to, really. And she's like, oh, what is that? And I also told her, I was like, oh, no, which one? And you're like, so like, I had to sit down.
Oh, that's.
I think it was. It's definitely out like. No, it definitely had.
She said when I was like actually.
Very short, and then they're really like, oh, that's what you have.
So you're looking for that choice?
He was like.
She was like, where is
It's hopeful, either, but.
It's really bad.
You're cold.
Oh, no, my dad's else. And we used to work so.
Yeah. Yeah.
Like first time.
Emergency?
Oh, yeah.
The biggest fines that we go like that.
That's what I.
It's really gonna take you.
You know, I have no idea. How to play.
I don't know. Then I was like.
You should have just said honey, what did you say, honey tea?
No, it wasn't.
All right. It's back to some acid base calculator.
Yeah.
So there are formulas I give them to you. And you're welcome to use them, since there's only two types of acidosis, respiratory and metabolic, two types of alkalosis. If you could recognize by the pH what you've got, you could apply the formula. If the formula works, then you have a metabolic acidosis. If the formula does not work, you still have an acidosis, it's just not metabolic, it's what? Respiratory. Now you pick that answer. Same with alkalosis. You recognize the pH 7.6. Is it respiratory or metabolic? You can apply the formula. The formula works. It's a metabolic alkalosis. If it doesn't, it must be a what alkalosis? That's the only two you have. So the metabolic acidosis formula, the PCO2 should be, and here's something, I tend to use the middle numbers. Like I know 7.35 is for 7.45, the range. I like 7.4. 35 to 45, I like 40. The only time I really use the upper or lower edges is bicarb. Because in bicarb, if I can make a case that there's an attempted compensation, and I know it's 22 to 26, I'll use 26 on the high side, 22 on the low side. So you're gonna see me most of the time using the exact middle number, except when it comes to attempted compensation, where I use the actual high or low value to see if there's an attempt. But you'll see that. So this should make sense. If it's about a lack of bicarb, metabolic alkalosis is a what? Lack of what molecule? Too much H pluses because there's too few. Metabolic acidosis, too few what? Bicarb. Well, that means the bicarb is going to be low. It's going to be less than that number. It should make sense to you. So the partial arterial pressure from that 40 is equal or greater than, 40 is greater than 1.5 times the measured bicarb, which would be low, plus 8, which is going to be a lower number because the bicarb is low. So 40 is going to be greater than, let's say, 20. The formula works. If it were respiratory, the bicarb would be up in an attempt to compensate for that respiratory. That formula would fail. But yet there's still acidotic. It's just not a metabolic acidosis. It's a respiratory. On the other side, whatever it is, I know the number's going to be high if it's a true metabolic alkalosis. So PCO2 40 is less than some number which has all that bicarb on the other side, which is elevated. 40 times 0.7, welcome to use it, times the measured bicarb minus the normal bicarb, 22 to 26. Pick a number. It's going to be greater than 40 because the bicarb is high, it's a metabolic alkalosis, the formula will work. If the pH is 7.6, but the bicarb is down in an attempt to compensate for a respiratory acidosis, the body will attempt to compensate by telling the liver make less, kidneys pee out more, the formula fails. Well, if it's not 7.6 because of too much bicarb, it's a 7.6 because of too little on the respiratory side. CO2, it's a respiratory alkalosis. It's an alkalosis, but the formula failed. So I don't use it, but you're welcome to, I will give it to you. Look at the pH. Usually the more profound culprit, not all the time, is the culprit, the more profound component. Look for whether or not the CO2 and the pH are going in opposite directions or same direction. Same with the bicarb. If the PaCO2 is higher and the pH is lower, opposite directions, it's a respiratory acidosis. Will the bicarb start going up in a respiratory acidosis? Why? Yeah, so you expect it, and there's a formula for the expected compensation attempt. Did it work? You don't know. Could it fail?
Yeah.
Could it work a little?
Yeah.
Could it work fully?
Yeah.
That's where my intuition comes into play. The PCO2 is down. I think the bicarb probably will be down a little bit, maybe not as profoundly, in an attempt to compensate for respiratory alkalosis. And again, this goes with every lab, with every ABG, with every EKG. Treat the patient, not the rhythm. It goes back to the patient first. If something doesn't look, the patient's going, hi, how are you? My name's Bob. They're not in severe respiratory acidosis. So always go back to the patient. So, can the body attempt compensation for a respiratory acidosis? It'll tell the liver to do what? Make more bicarb, the kidneys pee out less. So in a respiratory acidosis, I'm expecting the bicarb to actually go up a little bit. Whether it worked or not, I don't know. But I'm expecting the attempt. There's a batter at the plate. There's a formula for showing me that an attempt was made. Unsuccessful, a little bit successful, fully successful, I don't know yet, but I can see that attempt. So the expected attempt of the body to, in a respiratory acidosis, to tell the liver to make more bicarb, kidneys pee out less, is in an acute respiratory acidosis, 3 days, 5 days max. I expect it to go up by 1 to 2 millimoles for every 10 increase in CO2. So here's where I use the high number. They have an acute attack of asthma. It's only a day. Their PCO2 is, what's the normal CO2? Let's use 40, right in the middle. It's 60. How many groups of 10 did it just go up? 2. Now here's where I switch over to the high number. Are you ready? What's the normal bicarb? 22 to 26. Could it go up 2 for every 10? So could I make a case in front of a jury that if I see a bicarb of 30, which is 26 plus 4, 2 groups of 10, 1 to 2, let's use 2, that's my expected attempted compensation? I can make that case in front of a jury. That 30 of bicarb is not a metabolic alkalosis. That's the expected attempt of compensation for an acute respiratory acidosis where the CO2 went up from 40 to 60, 2 groups of 10. Does everybody agree with me? I can make that case. The pH is still in the toilet. I call it what? Uncompensated, there's an attempt, did it work? No. What if it moved a little bit, the needle moved a little bit, not all the way? Partially compensated. What if I see that attempt, I made my case in court, and the pH is 7.4? Fully compensated. So there is the expected attempt, whether it worked or not, I don't know. What if they have COPD and they're chronically respiratory acidosis? So for a longer time, the liver's been making more.
Right.
And the kidneys have been peeing out less. So the expected attempt, whether it worked or not, at compensation for a chronic respiratory acidosis, I can make a case in court that it might go up 3 to 5 for every 10 the CO2 went up. So that patient has had COPD, emphysema for 3 years. They come in and their PCO2 is 60. What's normal? 35 to 45, so let's use 40. How many groups of 10 is that? 2 groups of 10. So what's the normal bicarb range? Let's use 26. I'm gonna use the high range. Just for this, for compensation. Can I make a thing that 2 groups of 5, the highest number, 5, it could go up 10. Can I make a case in front of a jury that a bicarb level of 36 is still within my expected attempt at compensation? Yes. Did it work? It's not the right answer.
No, it's technically big, because that.
You don't know. You gotta look at the pH.
So if it's chronic and they're chronically elevated, isn't it always gonna be like that?
It depends on the pH. If they're 26, but it went up, the CO2 went up 2 groups of 10, and the body can do 3 to 5 for every 10, 2 groups of 5 is 10, 26% is 36. And if the pH is still in the basement, did it work? No. What if it's a little bit better? Partial. What if it's all the way back? Fully compensated. You don't know is my point. You gotta look at the pH. So in a court of law, a 36 bicarb is within my expected level of attempt and compensation for a chronic respiratory acidosis. Does everybody see how I got to 36? Now, which is harder to treat? Acidosis or alkalosis? So the attempt, whether it worked on compensation for the alkalosis, is even more dramatic. So in a respiratory alkalosis, the body will tell the liver to make less bicarb, pee out more. For an acute alkalosis, it might drop by 3 to 5 for every 10 the CO2 goes down, more dramatically, trying to stop that alkalosis. So I now will use 22. So if let's say their normal CO2 is 40 and they have a 30, that's 1 group of 10 down on CO2. Now I look at the bicarb, and I make a case in a court of law that 17 is actually the attempt at compensation. 1 group of 5 using the lowest number available. The biggest number attempt, lowest number 5, 3 to 5, 5. Let's use 5, 22, 17. Did it work?
You don't know.
You don't know. You gotta look at what? pH. What about a chronic alkalosis? Even more profound. You will really bottom out your bicarb because it's hard to deal with alkalosis. For a chronic respiratory alkalosis, it might go down by 5 to 10 for every 10 the CO2 goes down. And that's still an attempt, whether it worked or not. So, what's the normal CO2? 35 to 45, so can we use 40? I'm giving you a patient with a chronic respiratory alkalosis with a partial arterial pressure of CO2 of 20. How many groups of 10 did it go down? 2. What's the maximum number I can make a case for? 5 to, let's use 10, it's the max number. So can I make a case, it could go down 20 for that 2 groups of 10 that CO2 went down. Let's use the lowest number of bicarb, which is what?
2,
What's 22 minus 20?
2.
2. Can I make a case in a court of law that in a chronic respiratory alkalosis, a bicarb of 2 is actually within expected attempt of compensation? Yes, I can. Did it work? We don't know. You gotta look at the pH. I give you these formulas as well, but you have to know how to apply them. Now, here is my intuition. It doesn't work as well on the metabolic side. Sometimes on the metabolic side, you have to eyeball things. If I see a pH of 7.1, nothing is anything compensating a 7.1. No, so you have to use some of your own thought process as well. But for respiratory, there's my intuition. The pH will go up or down 0.08, and I always start with respiratory, in an opposite direction as the CO2 goes up 10. So for instance, I'm going to give you a patient now. The normal arterial pressure of CO2 is 40. My patient is acutely asthmatic and has, or pneumonia, and has a 50. Got it? The bicarb is, went up one group of 10, 28. What do I call that? It went up one amount of 2, 10 CO2, and I'm using 26. Can I make a case for that as an attempted compensation?
Yeah.
Yes. 1 to 2 for every 10, it went up 10 acute. So 26, the highest number, 28. Can I make that case? There's my attempt. The batter was at the plate. Now I look at the pH. What's the normal pH? This is what you were waiting for.
7.4 you want to use.
7.4, and I see a 7.32. How much did it go down? 0.08. It went down as bad as I would expect it to do in an uncompensated respiratory acidosis. It did not help. There was an attempt at compensation. I made my case, but the pH is exactly where I expected it to be. Right in the basement, from 10 up in CO2, down 0.08. Everybody see that? Next patient comes in. He has COPD for 3 years. His PCO2 is 60. What's the normal? He's in what condition? Respiratory acidosis. It went up 2 groups of 10. So I can make a case, the adjustment 3 to 5 for every 10. So I can make a case that if you use 2 groups of 10 at 5, 10. And I'm going to use 26, the highest number. The bicarb is 36. Can I make a case that 26 plus 10, 3 to 5 for every 10, and went up to 60, is the body's attempted compensation? I can make that case. Now, it went up 2 groups of 10. Shouldn't the pH go down 2 groups of 0.08? But it went down to only 7.32. I'm expecting, if it was as bad as possible, a 7.24. It's a 7.32. Is 7.32 normal? But is it better than expected?
It's partial.
What are you going to call that patient? Partially compensated respiratory acidosis. I think you guys are getting it. Third patient comes in. They don't even give you a history. He's unconscious. But his PCO2 is 60 and his bicarb is 36. My question, but the pH is 7.4.
Fully compensated.
Whatever it is, it's a fully compensated what? The bicarb is up. The pH didn't move. Remember, the pH goes in the same direction of bicarb and in opposite direction of CO2. The pH is 7.4. Now I'm in a quandary. What do I have? A fully compensated what?
Look at base.
Who says it's a respiratory acidosis with a fully compensated metabolic side?
No.
Who says it's a metabolic alkalosis with a fully compensated respiratory side? Who says I'm not sure? Christian is right. It's a fully compensated respiratory acidosis with a pH of 7.4. Why can't it be the metabolic alkalosis? The body won't do that. You just answered like 7 questions on my exam. You guys want to do more? Should we stop here while we're ahead?
It looks like a little test, man.
What?
You can give us just a little test right now.
Well, there's more components. So metabolic acidosis, there is a compensation. You gotta use your brain though. There's no 0.08 formula. If the metabolic acidosis is happening, what happens to the pH? It's going down. What's happening to the bicarb? Down in the same direction. But guess what the CO2 does? Down as well, it's attempting to compensate. Look at the pH. If the pH is 7.4, it worked. Well, what if it's 7.2? There's no formula. Look at the pH, use your brain. If it's normal 7.35 and they have a bicarb level of 10 and a pH of 7.3 and a PCO2 is 20, it's compensating partially. If the pH is down around 7.09, is it compensating? No, sometimes you have to use your brain. I have a formula for the respiratory side. The full metabolic side, you just have to recognize it. When the pH is that bad, whatever the body's doing is not working. If it's 7.3, something's working. If it's 7.2, something's not working. Go ahead and take a stand and say, this is an attempt, but it's an uncompensated metabolic acidosis with an unsuccessful swing and a miss respiratory side. It just didn't work. Yes.
Are the formulas kind of like there to help us, or do we need to use that?
You do not use my formula right there at the bottom. That'll get you everything you know. I'm giving it to you just so you have an option. So again, metabolic alkalosis is there a body's attempt at compensation? No, the player never even gets to the plate. Sit in the dugout, you're out. So how do I use it? Again, if the bicarb is higher than expected, I'm either thinking it's a metabolic alkalosis or an attempt at a respiratory acidosis attempted compensation. The bicarb's lower, it's either a metabolic acidosis with an attempt on the respiratory side, or it's a respiratory alkalosis with a compensation. Acute, a couple of days. So I give you something a day, 2, 3, use the expected acute formula, whether it's a respiratory alkalosis or acidosis. Anything more than 3 days, go chronic. And use the higher numbers. So there's your ABG. 7.35 to 7.45. 7.4 is what I usually use, right down the middle. Acidosis or alkalosis. Partial arterial carbon dioxide at sea level, 35 to 45. Respiratory at 30, and whether there's a compensation. It could compensate by breathing off CO2 on the respiratory side for a metabolic acidosis. And it can compensate by keeping CO2 for a metabolic alkalosis. No.
Oh.
Call me a liar. Will the body accumulate its own CO2 from metabolic alkalosis? It won't suffocate itself. You're supposed to say, no, Phil, you're wrong. Arterial pressure of oxygen at sea level, respiratory efficiency. If it's less than 60, they're not ventilating well. You gotta vent them. Bicarb 22, 26, the metabolic response. It can be higher expectedly in a respiratory acidosis and lower expectedly in a respiratory alkalosis. If it's not too much on the metabolic side is a metabolic alkalosis. Too little on the metabolic side is a metabolic acidosis. But only one of them has a compensational effect. The rest, the metabolic acidosis. Base excess. Again, higher numbers, more OH. More OH means less H plus. So it's indicative of a metabolic alkalosis. If it's 4, 5, and 6. More OHs, which are bases. Alkalosis, more base. If it's -4, -5, -6, you have no base excess around. Something's eating up your OHs. That's H plus. The more H plus you have, the more acidotic you become. And if you're metabolically acidotic, your base excess will become a more negative number. And that's how it's used. Confirm your metabolic acidosis or alkalosis. And the anion gap really only gets calculated for which condition? Metabolic acidosis, to tell you what information. Who's causing it? There's no lab, there's no number, there's no vial of anion gap you can carry with you to pharmacy. It just tells you who the villain is. You have positive gap, metabolic acidosis, and no gap. And now you know where to treat. So again, pH. If it's respiratory, I know for every 10, the CO2 moves the opposite direction of pH. It's an acidosis and alkalosis. And for every 10 it moves, I'm expecting a 0.08 change in the pH. If I get that, or close, if you get on your exam 0.07, 0.06, just go with the 0.08. Close enough. Then it's as bad as I expected, no matter what the bicarb is, even if I CV at 10, it was uncompensated. It's as bad as I expected. If it's better than I expected, the pH, but not all the way home, I CV at 10, it's partial. If it's all the way home, it's fully. That's how you find out whether the attempt, the attempt was made, and I give you the formulas, whether it worked a little, but didn't work at all. So CO2, I look at next. I look at the bicarb. I match the CO2 to the bicarb with the pH. What's going up, what's going down? Does the CO2 and bicarb same or opposite direction of the pH? Respiratory side, opposite. Metabolic side, same. In a respiratory acidosis, they go in opposite directions. They're over on the board. In the metabolic side, same direction. And then the oxygen and O2 saturation. Now, that just tells me whether or not I really need to intubate them, whether or not it's a pulmonary embolism. If I see a PO2 less than 60, I'm thinking pulmonary embolism. That's what's about. And then again, treat the patient, not the liver. So again, pH, acidotic, alkalotic, look at your patient. You know what? I don't even go right to ABG analysis. You know what the first thing I use in my diagnostic toolkit? The patient. Your patient has diarrhea. Before I even get started, I'm thinking of non-iron gap metabolic acidosis. Your patient has COPD. I'm thinking respiratory acidosis. Your patient has diabetes. I could get proven wrong, but what am I thinking before I even leave the room? In my history, metabolic acidosis with a respiratory compensation, which is called what pattern? Whose mouths? Look at your patient. Again, my intuition, for every change in CO2. If it's as bad as possible, 0.08. That's uncompensated, even if I see the attempt, swing and a miss. If it's not as bad as I thought, maybe partial. If it's all the way home, fully compensated. I see the attempt because the bicarb could go up. But if it didn't work, pH is as bad as that for every 10, 0.08. So if I see somebody with a 70 CO2, the bicarbs elevate. I expected that. But the pH is 7.16. Did it work? No, that's 0.08 is 7.32. 0.0 is 7.24. One more, because it's 70, 0.16. Bad as it could be. Next patient comes in. I see the attempt at compensation. They're 70, but the pH is 7.24. It's not as bad as my formula. It's what compensated. Not home, it's partial. Third patient comes in 7.4. Holy,
You give like a page right on the cusp. For partial.
if it's not as bad, like if 70, can I make it 7.16 be as bad as my formula would predict?
Yeah.
But they're not, they're 7.24 with a 70. It's moving in a better direction. That's that whole. That's how you use my formula. It tells you on a respiratory side whether there's an attempt that failed, swing and a miss, an attempt that got a single, partial, or attempt that hit a home run. So, some formulas, HOH, you gotta know. pH is just based on the separation of H and OH. OH is your base, excess. This is very important. Metabolic side, H pluses. That's your acids. The more you have, the lower your pH. Bicarb is your primary buffer. Carbonic acid, carbonic anhydrase, H2O and CO2, but the equations can go in either direction. You get too much CO2, you'll have too much H pluses. You have too little bicarb, you'll have too many H pluses. That's acidosis or alkalosis. So base excess is just telling me how many OHs are on the base, because too many H pluses will eat the OH negatives. Turn them back into the water. Your base excess will go down. Too few, you'll get more H's, the base excess goes up. Again, that's what base X, again, metabolic side, you're looking for, is it in between -3 and +3 for a metabolic acidosis or alkalosis? It doesn't tell you what you need for the respiratory side. That's where you gotta look at CO2, pH, and bicarb. So again, a 4, they're metabolically alkalotic. A -4, they're metabolically acidotic. But I don't look at base X to help me with a respiratory issue. That's CO2, pH, and bicarb. Is there attempted compensation? And I put attempted on your exam for the formula, because it doesn't always work. That's why you use the 10 change in pH for 0.08. It could work a little, could work fully, could not work at all. And each would have the same attempt. Depends on the patient. Anion gap, metabolic acidosis. If it's respiratory, I already know the culprit. It's respiratory. It's whether or not there's a positive, a gap or no gap in a metabolic acidosis. And again, it's not anything I can carry or point to. It just tells me the villain. So I know where to treat. Here are your mnemonics. If I get a gap with a if I have a metabolic acidosis, what do I have to calculate next? The anion gap, it's positive, it's 20. That's a positive gap, metabolic acidosis. mud piles are your culprits? What if the gap is 12, but they have a pH of 7.2 and a bicarb level of 10? They have metabolic with a bicarb level of 10 and a pH of 7.2. Acidosis, the PCO2 is 20. Are they attempting to compensate by blowing off CO2? Did it work? With a 7.2? No, there's no formula. Just look at 7.2. You calculate the anion gap in this metabolic acidosis. Yes, any metabolic acidosis. And the gap comes back at 12. It's not a gap. It's a different mnemonic for this metabolic acidosis. Hard up. And guess what the D of hard up stands for? The most common. Diarrheas. That's how the anion gap works. From metabolic acidosis to find the culprit. So, I was it was one of those conventions. I was sitting in the audience, all these physicians, PAs, people are practicing much longer than me. And some guy came on and thought he'd be fancy, and he was gonna give a patient to see who would come up with the diagnosis. And he throws up a little urine and a BMP and an ABG. And the person had an acidosis that was metabolic, and there was a positive gap. She was 22 and she was outside and they found her in the garage. So I raised my hand. He hadn't even started. And I said, she drank antifreeze, tried to kill herself. And everybody's like, how could you figure that out without any information? It's because I know propylene glycol is one of mud pilers, antifreeze, which happens to be very, very sweet. Don't let your toddlers out into the garage if you'll be antifreeze. They will lick it. Don't let your cats out. They will lick it. And they will put themselves into a positive gap, metabolic acidosis. And now you have to treat it with dialysis, flumetrazole. It's very lethal. And so methyl alcohol is the M. What alcohol? You get a blood alcohol content. If it's greater than 400, they need dialysis right away. Don't pass go, do not collect $200. They'll fry their kidneys. But even with that, does anybody know now you found the reason for this positive gap? Metabolic acidosis. The gap will be high, the pH will be low, the CO2 may be low too, but it may not be enough to compensate, and the bicarb level will be very low because the H pluses you just shoved into themselves, ate up all the bicarb. Now the H pluses are running around like crazy. Anybody know what the treatment is? Besides dialysis, so you get a BAC or blood alcohol content.
Get bicarb?
No. You actually get them drunk. Actual ethyl alcohol is the competitive antagonist for methyl alcohol. You drive off, they have in the emergency department, they have medical grade whiskey. And they put something in it so that you can't take it home with you and have a party. So it only works in medical situations. And you get them drunk, and you can deal with a drunk better than somebody who's dead. And it drives off the receptor. And they probably are still gonna get dialysis, but it's not emergent if it's if it's over 400 BAC, emergency dialysis will be died. Uremia. You gotta get the urine out. What has to come out? This and pus have to come out. Urine in the bloodstream will kill them and cause a positive gap metabolic acid. So if they're retaining urine and they can't pee because there's a stricture or a stone or something, put in a catheter and get that urine out. DKA, diabetic ketoacidosis. So you get a BMP, the potassium is elevated, the pH is down, they have Kussmaul's respirations, acetone breath, they're diabetic. And they just went and had like a buffet with a Viennese table dessert. and they forgot their Geo insulin. Their blood sugar is 600. That's someone with a positive gap. Now, DK is funny, it can be non-gap or gap, but most of the time, it's positive gap. Anybody know the treatment?
With DK, fluids and so on.
Lots of fluids to start with till you get your potassium. Do not give them anything, insulin drip until you get that BMP, because you'll bottom out their potassium. Your fluids, then an insulin drip. And what if their potassium level was 6.5, and now after an hour of insulin drip, it's 5.9?
Very good.
Very good. Why? You know what's gonna happen to that potassium. It's going to plummet. Do not wait. What's one of the ways we treat hyperkalemia? That's how we start. That just stabilizes the cell. One of them is insulin and glucose. Well, they're loaded with glucose. We give them insulin. Their potassium is gonna drop. It doesn't know it's normal. It doesn't know you're not treating it. Start early with that potassium supplementation. But fluids first, till you get that PMP, then an insulin drip, and potassium is necessary. Formaldehyde or propylene glycol, antifreeze. So I said for methyl alcohol over 400, you need emergency dialysis. Does anybody know when you need emergency dialysis for someone who can get antifreeze? 20. And if they have 20 or more, they will blow out their kidneys. Emergency dialysis. And you can also give them medical grade whiskey. It's a competitive antagonist. But now they have something else called flumetrazole, which is what I yelled from the audience. The doc comes up to me afterwards and said, "Do you want to be with our group, go around teaching?" I said, "No, I already got them." They need me here. I can't go around the country. I don't want to go around the country. I hate it. No, the country's good. I don't want to go anywhere else though. You ever hear of PAs, Doctors Without Borders? Now, I belong to an organization, PAs with Borders. I'm not going anywhere. Isoniazide. History. What does your patient have? DB. Lactic acid. Your people who work out, take all those muscle drinks and energy drinks. They're always in the ER for a metabolic acidosis. Because they overdo it. The body cells will make energy whether they have oxygen or not. And what's the byproduct of anaerobic respiration? Lactic acid. Ethyl alcohol. So you give them lots and lots of fluids and supplement their magnesium and vitamin B. They're in your ER for a long time. They get a banana bag. Flushing out, it could be there a day, because what organ's the most efficient, but it takes 12 to 24 hours. Kidney. Rhabdo. Oh, man, I can't get up. What's the number one overdose in the elderly? Aspirin. Aspirin, known as ASA, stands for what? The acetylsalicylic acid. So they take an aspirin a day, then they got a headache and they took some aspirin, then they had a stomach upset, so they drank some Alka-Seltzer. What's an Alka-Seltzer? Aspirin. And now they're in your ED, breathing like this. Trying to compensate, they're in a positive gap, metabolic acidosis. All right, you mentioned bicarb. Should you give them bicarb? What do you think, Alyssa?
Don't you have to get like, don't you have to get more?
It depends. Are they alive? So what are your parameters?
15.
Less than 15, you should,
Interview.
or pH less than.
7.1.
There you go. Here's your answer. Now, patient comes in. They have a metabolic acidosis. The PCO2 is 20. They're attempting to compensate, but the pH is 7.2. That's not real. I don't have a formula, but does everybody agree is 7.2? Whatever the body's doing isn't working at that moment.
Yeah.
Uncompensated metabolic acidosis. You check the what. We're talking about it right here. the anion gap, and it's 12. What do we call this? Positive gap metabolic acidosis. Hard up. Hyperalimentation. So,
Wait, isn't it not? You
non-ion gap, the gap is normal.
just said.
You said high.
Oh, sorry, non-ion gap metabolic acidosis. The gap is normal, they're still metabolically acidotic, it's just the gap never changed. Whatever they're losing is in equal proportions. One. What happened? Oh,
Everything's okay.
you're okay?
Yeah, we're okay, thank you.
I thought she slapped you. I'm like, what? I said, you guys should try to get along better than that. Hyperalimentation. So can we give them things like Caxlate? You give Caxlate for hyperkalemia, it's one of the best, it takes a day, but it makes them poop. What goes out in the poop? Give me two things. Potassium and bicarb. Hyperalimentation, we did that. So we stuffed that, they're going in for a colon surgery, what did we give them? Go lightly, they poop their brains out. Could we overdo the go lightly and put them into a metabolic, non-ion gap, metabolic acidosis? You gotta be on top of that. So that's iatrogenic, we did that. Acetazolamide. You know who takes acetazolamide? Anybody ever been to Peru? What is that town? It's way up in the
Oh.
Machu Picchu.
Yeah, whatever.
It's for mountain climbers, when people going up really high. My sister called me, we're going to Machu Picchu, should I take acetazolamide? I'm like, no, just go up there, you're young and healthy. What are you worried about? You have to slow down and take a breath, slow down and take a breath. Do not take acetazolamide. Now you're playing with fire. Non-ion gap metabolic acidosis. Renal tubular acidosis. So RTAs, those RTAs, number 4 is really hyperkalemia, but RTA 1 and 2 are the most common. Renal tubular, it's the kidneys aren't working the way they're supposed to. And they're not making the uric acid and taking all those, again, the most efficient, but it takes the longest. Sometimes the kidneys just don't work. Ureteral fistulas, abnormal connections, post-surgery, history. Everything's packed in your abdomen. When you're tissue splitting, surgery, you only really cut the top. You cut the skin, the dermal layer with the scalpel, you cauterize it. Once you break through the fascia of Scarpa, you tissue spray. Guess what breaks open? The cells, and leaks serous fluid. Have you ever felt serous fluid? Guess how it feels. Sticky. It's sticky, those intracellular fluids, and they bind organs together, and sometimes unnatural tunnels develop. And one of those fistulas could happen at any time you have any kind of intra-abdominal surgery. And one of them could lead a ureteral fistula, you're bringing back all that acids, a non-ion gap metabolic acidosis. Same thing with the pancreas and duodenum, an unnatural channel, bringing back your poop. Pancreas and duodenum, that can also cause a non-ion gap metabolic acidosis. Here's your renal tubular acidosis. Again, 4 is mostly about hyperkalemia. So you treat the hyperkalemia unless you find out it's a hormonal problem. What hormonal deficiency can cause hyperkalemia? Decreased what? It starts with an A. Aldosterone. Aldosterone brings back sodium, potassium to the toilet, but it's not there. So you become hyperkalemic, hyponatremic. You have to give them aldosterone exogenously, but treat the hyperkalemia. But renal tubular acidosis, 1 and 2, very common for non-ion gap metabolic acidosis. And rarely seen to go for the boards, take his advice. These are Mike Lay slides, take his advice on them. Again, respiratory acidosis. There will be an attempted compensation. Acute, 1 to 2 for every 10. I can make a case for 28 for a PCO2 of 50. Chronic, 3 to 5 for every 10. Expected, whether it worked or not, compensation for alkalosis even more dramatic. For every 10, the pH goes, the CO2 goes down. I expect the bicarb to go down as well, 3 to 5 and 5 to 10 for chronic, because it's harder to treat. So there is compensation attempts, whether they worked or not, for the respiratory acidosis and alkalosis. And the pH, I expect, if it's as bad as could be, for every 10 the CO2 goes up, the pH should go down 0.08 and vice versa. If it's as bad as expected, it's uncompensated. If it's better than expected, but not all the way home, partially compensated. So all the way home, it's fully compensated. So again, pH 7.35 to 7.45, partial arterial pressure of oxygen, partial arterial pressure of carbon dioxide. So for bicarb levels, I use the top and bottom number, but for these, I use the middle number, and you'll see how I do that. Bicarb 22 to 26, base excess -3 to +3, saturation 95. That's different. That's oxygen saturation percent. Anion gap. The more precise formula is all your cations added together minus all your anions. However, if you do that precise method, it changes the range. The conventional method is to ignore potassium and just have chloride and bicarb together and subtract it from sodium. And if you use that formula, which is the formula I use on my exam, the range is what? 9 to 16. So presence of an anion gap, again, when do I calculate the anion gap? What condition?
Well, that's
Metabolic acidosis. To try and find the culprit. What can give me a positive gap? What's the mnemonic?
Tyler.
What about a non-ion gap mnemonic? All right. There is your metabolic panel. If there's a discrepancy in bicarb, who's more accurate? The BNP. I give you the normals, you have to know what's in the skeleton. You have to know that a creatinine of 1.5 indicates what? Acute kidney injury. What does the BUN reflect? Hydration status. What is abnormal? Over 20. When do I start getting worried? Over 18. I even wait for 20. Yes.
Another slide said that chloride is 95 to 105. That does it really matter?
Again, Mike, it is 95 to 105. You know what it is? Actually, it's lab dependent.
Yeah.
We're talking, you're splitting hairs, 95, 98.
UK.
I go by 95 to 105. Oh, if you add the liver, what is your BMP now?
What would you say?
If you add AST, ALT, and alpha, your BMP becomes a what?
Oh, CMP.
CMP. Which of these comes first? It's the AST. It's very early, but is it liver specific? Which comes next? Also early, but is liver specific. ALT, which comes much later, is not liver specific, but in the context of liver disease, it means itself that the hepatocytes are becoming defective. ALT-FAS. You should know that as well. It's late, and it's not liver specific, but in the context of liver disease, it means the hepatocytes themselves are being disrupted. The ALT is early, not as early as the AST, and it is liver specific. The AST is the earliest, but it's not liver specific. Electrolytes, potassium with magnesium, you should know that they're BFFs. We talked about that last week. Calcium, again, it could be hypocalcemic because of the parathyroid gland. And what's the fuel for the parathyroid gland? Magnesium. So what's the number one cause of torsades? Hypomagnesemia. What's the second most common cause? It ends up magnesium's lap anyway. All right. K plus. Could it be a fraud elevation in the presence of an acidosis? Yeah, because those hydrogens booted out. And it's actually at risk for hypokalemia because when the potassium ions get bullied out of the cell because of the extra H plus, they're not protected from what organ? And now they're peed out and they're out of you. And as you solve the problem, guess what happens to your potassium level? Plummets. Alkalosis is the opposite. They all go into the cell. And again, magnesium and potassium are BFFs. Acidosis, we talked about that. You have the right amount of calcium. It's just the distribution isn't right. In acidosis, you should get an ABG. The amount ionized, working, doing stuff is higher than bound. The lab doubles the bound and tells you you're hypocalcemic when your symptoms are hypercalcemic. And you're neither. It's just inappropriately distributed because of the acidosis. And in alkalosis, it binds it all. The lab doubles it, tells you you're high, but you only got a few left. You're active that are active, your body says low, and you're neither. It's just inappropriately distributed. Always check with kalemia, your pH. Correct the acidosis or alkalosis. Watch out for hypokalemia as you correct an acidosis, because you know it's going to plummet. Again, same thing with hypokalemia. If you correct the acidosis, don't try to give them more bicarb yet. Correct the alkalosis. Magnesium. And the kidneys will urinate potassium if it's not in the bloodstream and not in the blood cell, is what it should say. Meaning that if you have an acidosis, it'll bully out the potassiums, the kidneys will see them because they're not protected and pee them out. And as you fix the acidosis, your potassium level is going to drop like a rocket ship. Always check with calcium. Check your albumin levels. You got to balance calcium for albumin. Treat the acidosis and alkalosis first. Hypocalcemia, again, check the acidosis. It can fool you. Same with hypercalcemic system. And again, it's neither, it's just inappropriately distributed because of the acidosis or alkalosis. Treat those problems first. Acidosis, again, it's respiratory or metabolic. Alkalosis, respiratory or metabolic, and there's compensation. In the respiratory, body will tell respiratory acidosis, liver make more, kidneys pee out less. And I know the formula. Respiratory alkalosis, make less, pee out more. Metabolic acidosis, breathe faster, blow off CO2 on the respiratory side. Metabolic alkalosis, retain some CO2. Good, that's the answer. Won't do that. I see someone in that going, that's correct. Won't do that. All right. Let's take 5 minutes and then we'll do some cases. Just as a warning, I'm going to be picking you guys to do the cases.
I have a question. For compensation, do you have to use the 0.08 or can you just, like, for example, for this one, you look at,
the attempt.
like,
You just don't know how well it works.
but I'm saying like this one, like you see the bicarbs.
It's out of range and it's trying to help, so you know it's compensating, but not correctly.
Enough, I think, an attempt,
Yeah.
the battery all of that.
No, but
If you use the 10, we don't know.
So
You
you
apply
use
the
it
10 0.08, And it will tell you
Oh,
like
thank
whether
you.
there was a strike, a single or a home run.
It's partial because if it's supposed to be 2-4 and ultimate, 0.08 twice, but it's better than expected.
Well, you're already ahead of the game, Christian. You're already recognizing that's why I employed my formula.
Well, I think also what she's saying is like, do you need to apply that, or can you like see it, like it's like,
You don't know whether it's working or not without applying my formula.
okay, oh, cause you don't have something to compare it to. Right, right?
If it's less than I expected, I know it's partial. If it's as bad as I expected, it's all. If the pH is back to normal, it's full.
I get what you're saying.
So it's like hardcore carbohydrates.
But I feel like for like the last.
As in carbs too. Yeah.
There's so.
Let's make it short.
There's a method to your madness, though.
Like, we just look at it and be like, which ones are out of range?
Like now we're up in the ante.
Yeah.
So like, yeah, because like in this example, like honestly, yes, like his example is like,
I can use.
but according to this, yeah, right, according to this formula, it would drop down, it's supposed to drop down by 0.082 times, that would be 0.2, that would be
For
a
this.
7.24. Better than 7.24, so it's partial. That's why you have to use it.
I get why it's, I
Yeah,
get it's
so-
partially.
Because there's no other patient compared to it. If you had a patient comparing this, then you'd be like, all right, it jumped up a lot or it didn't. But now I see why he wants to see.
Because,
it.
so it can.
If you only get, if you do one draw, and you have no other patient to compare it to, and that's what you get, you're not gonna know if it's compensating or not,
Yeah.
unless you apply. So that makes
Like, that's fun.
Yeah, but I think we were all thinking the same thing. Like,
Yeah.
well, not necessarily, but you can see it's coming. And now it makes sense. If you don't have something previously,
Like, you're only using.
then like you do this and like another pH and then it jumps up again, then you'll be able to. Right? And this
Okay. So two to six.
it makes sense, makes
Yeah.
sense. Now I see why. Now I see why.
Could be 10. It was 3.08.
Yeah, all that.
That would be the 7.4 drop.
I think pH is great.
Here,
Like that long gap.
Then it would have been. Yeah, we're talking like raw. Right, that's what the point is.
I just didn't know.
I think, like, I get it. All that.
The RTD.
Yeah, and I was like,
if it's like not.
I'm not supposed to, yeah.
Yeah.
Whatever, but I was like, I
always do is like, oh, my carbs high, so compensating, it's not bad. But like, okay.
Yeah.
He makes this interesting.
Yeah.
Makes-
There's an attack, but it failed.
He hasn't called you out,
So no comp.
This doesn't want.
I missed the tarot. Not that ion, yeah. Like I have to. Well, no.
I just don't want to hear it.
I didn't realize that it was like.
I thought
I only have this.
Okay, so basically, look, let's say you draw this MPG on someone that just came in, you have nothing to compare it to, right?
Right.
But ideally, you know that it's really low,
Yeah.
and you see that the CO2 is in the byproduct. His formula, basically, to apply, so it went up by 20, right? His normal CO2 would be 40 in the middle, it went up by 20. And then the bicarb went up to 28, it went up by 2.
Right.
So then you would see that it went up by 2, so then you have to do the 0.08 twice. So you go in the opposite direction of CO2, right? CO2 went up, so pH is down. So you're normally,
That's the CO2 or the.
no, so like essentially, when you look at the CO2 and the bicarb, you know, like it went up. It went up by 20, so that's where you do the bicarb to figure out. It went up by most food. It went up twice, right?
Right.
Right? So then, so then his part comes into play is normal pH is 7.3. If you put it went down, it went up by 20, so you do 0.08 twice. Down though, subtract it down. So you subtract it the first time, it would be 7.32, and then you subtract it again by 0.08. That's supposed to be 7.4, right? And then that's the 7.26. So his formula is to say, oh, it's better than expected, so this is a partial.
Okay.
But without knowing, without doing that, you could just say, oh, it's.
I get that, all that. So you're still trying to, yeah.
From separate pH, the normal pH is seven point two. Yeah, that's.
Then you'll.
Oh, better than expected, that when you do this formula, the 0.082 times, at worst, it's supposed to be at like worst, it's not. But it's higher than that, so it's better than expected, like you're expecting it to be that bad. No, there's a lot,
Pretty
there's
fast.
a lot of.
I just wanted you guys to get your heads and you can actually do some real case analysis. Acid base case, because figuring out what you've got leads to your treatment plan. And all of these are post-surgical cases. So they're really what happens to people during or before or after surgery. So I'll do the first one. So previously well, 30 minutes, I already kind of think it's acute. Respiratory distress, always goes back to the patient. So I'm already leaning respiratory. pH is 7.26. They're what? Acidotic. The PCO2 is 60. It's going in the opposite direction. What is it? Metabolic or respiratory? It's a respiratory acidotic patient. The bicarb is a little elevated. It's 28, what's normal? 26, even if I use the highest number, it's over that. Anion gap is 14. I really don't care. When do I check the anion gap? Metabolic acidosis. To treat the patient, my intuition, both of them, which you already saw, is can the body attempt compensation for respiratory acidosis? Yes, it'll tell the liver to make more kidneys to pee out less. It's acute. So for every 10 that it goes, CO2 goes up, could the bicarb go up 1 to 2?
Yes.
So how many groups of 10 did it go up?
2.
So I can make a case for 4 then, 2 groups of 2. What's the highest number of bicarb? 22 to. So if I can make a case for 4 and I add it to 26, can I make a case that if I saw a 30, that's the body's attempt at compensation? It's only a 28. Isn't that within my legal domain to say, there's the attempted compensation?
Yeah.
It's higher than normal. I expected that. I could sell you up to 30, couldn't I? And it's only 28. Right? That's the attempt. Now, let's check. How many groups of CO from 40 did 10 go up? 2, 50, 60. That means if things were as bad as I expected by intuition, how much should the pH drop? 2 groups of 0.08. 7.4 minus 0.08 is what? 7.32. That's 1. I still have 1 more coming. What's 7.32 minus 0.08? 7.24. What is that patient's pH? It barely, at this moment, it barely moved. 4, I might start saying a little bit of a movement. But I remember I mentioned this before, 1 or 2. That's too small. Can we ignore that? Can I predict what's going to happen tomorrow? Can I tell you what happened an hour ago? This is the ABG. So I don't know these things. All I know is at this moment, this person has what based on that pH? And what? Uncompensated respiratory acidosis.
Isn't it within your range though?
1 or 2 does not. I'm expecting a 7.24. 7.26 does nothing. It doesn't impress me. A 7.30 would impress me a little bit.
It was 7.27.
I might have to wait till 8. A whole half a day.
So then,
If a whole thing is 0.08, I might be impressed by half of that, 0.04 movement. Anything less than that, ignore.
so only because it's that small range,
I ignore it.
but if it wasn't, then it's still better than when you expected.
I'm confused with your point. What's like the cutoff, that's like, okay.
Yeah,
A whole
that
half
means like how
is 0.08 is a whole range of 10. That I would say is 0.04 or more.
So that's also 7.6.
So if I'm expecting a 7.24 and I see a 7.29, I might call it what? Partial.
So your
But it's
limit is 3,
7. What?
your limit is what? The limit should be
0.04 or greater.
0.04 or greater, okay.
So 7.28, that would be partial.
That would be right on the borderline.
Or is your test gonna be borderline or?
No.
like-
It will be obvious.
Okay, 1 or 2, no.
Ignore 1 or 2. 4 or more, I'm not gonna give you 4 and stress you out.
Okay, thanks.
It'll be obvious.
Could be the carry.
1 or 2 does nothing for me. 0.06, a whole 0.08, that impresses me. I will not give you 0.04, so you're like, ah. It'll be either partial, full, or on, and 2 does not impress me. So that is a what patient?
Then
Uncompensated respiratory acidosis. Did the body attempt compensation?
Yes.
There it is. Did it work? No. So treat the patient. pH went down 0.08. Oh, 2 groups of 10, and almost, it was, I don't know where it's moving, but at this moment, it's uncompensated. Bicarb went up, but it was 28. I could make a case for 30. That's the body's attempted compensation. They swung, they just didn't hit the ball, like a baseball player. I don't care about the base excess. I'm looking at that for metabolic stuff. pH down, we know it's an acidosis. Respiratory, the CO2 went in the opposite direction, 2 groups of 10. Expected bicarb compensation, acute, 1 to 2 for every 10. I can make a case for 4, 26 plus 4 is 30, it was only 28. I can make that case easily. Compensation is expected, gap, I don't care. And because the pH was only 7.26, and I'm not gonna give you 7.28 on that case. It'll be 7.32. Or 7.4 or 7.26. Which doesn't, that's too much of a
Only 2.
group. So, things that could cause an acute post-surgical respiratory acidosis, pneumonias. What are the 6 W's of post-op fever? What if they're in pain? Let's say you did an abdominal surgery. What kind of movements do you use your abdominal rectus muscles for? Everything, including breathing. So what do people do if they're in pain? They're not treating it well. They splint themselves. And then fluid collects in the bottom of their lungs. And what's fluid that doesn't move? It's a nidus for infection. The most common reason people infection nosocomial is what? In hospital. Indwelling catheterization. What's the #1 nosocomial infection? Killers. Pneumonias. That means nosocomial means they got it in the hospital. So UTIs, #1 from catheterization. Most common. The most #1 nosocomial killer is pneumonias. COPD. Get respiratory involved because anesthesia won't intubate people unless respiratory is involved. You want that surgery to take place. All respiratory. It's a COPD patient who needs a lap chole or an open chole. Better get respiratory involved. Pulmonary embolism is obvious. Obstruction is actually #1. They have a post-op respiratory acidosis, but they're still intubated. You know what you have to do? You have to put saline and clean out the tube. All that gunk can get stuck in there. The number one causes of a respiratory acidosis post-surgical is actually an intubated patient, is a mechanical obstruction. And there's actually a little device on every tube to put saline and thing it down. But you've got to order it. The nurse doesn't do that on her own, its own. You gotta clear that thing out. Obstruction, very common, go. Sometimes it's low peak. Again, tell the respiratory to put up the positive end expiratory pressure. Normal is 5. No, we had our patients on that were coming in with COVID. 20. I thought, how are these people not exploding? But we try to force oxygen through that inflamed lining of the alveolar sacs to get it to go into the bloodstream. They were peeping them at 20. So sometimes you have to up the peep. That's on us. Things that block oxygen from getting to the bloodstream can cause a respiratory acid. CO2. If oxygen can't get to the bloodstream, then CO2 get this way. Then it stays in the bloodstream and it's an uncompensated respiratory acidosis. Especially if the liver and kidneys can't keep up. They try, they just can't keep up. So the formula with a bicarb level that high will not be less than 40. It'll be greater than 40, which means the formula doesn't work. Well, do you still agree they're acidotic? The formula failed. Well, they're not metabolically acidotic, they're what? Respiratory. That's how you use the formula. So you can see right there, with a thing like that, it's not going to work. The formula will not work. It's not going to be greater than the number. Acidotic, it's got to be respiratory. Formula failed. Compensation, 1 to 2 for every 10. Went up 20. I can make a case for 4. 26 plus 4 is 30. I can make that case that there's an attempted compensation with a 28. Whether it worked or not, I have to use the intuition. I can say that at 7.24, that's as bad as expected, and with a little smidgen 2, I'm going to ignore it and say it's uncompensated. There was an attempt, swing and a miss. And that's how I use the 0.08 for every 10. pH 0 up, 10 down. You made your diagnosis. You know what you need to do. You need to re-intubate them. You need to clean out all those secretions from their oral pharynx. Do you need to give them a bronchodilator? Do you need to perform chest PT? Do you need to give them humidified oxygen? Do you need to start them with some anticoagulation for a PE? Things that cause acute respiratory acidosis. You need to give them a steroid for inflammation, and so on and so forth. Retention of CO2. Common causes. Respiratory depression. What are we giving them for their pain? What do you want to give them for their pain? They don't split themselves. Pick something. That's what happens if you give too much morphine. They stop breathing. It's a respiratory depressant. What if they're anxious? What can you give them? You want to give them some Ativan? Guess what Ativan is? A respiratory depressant. If you go in, your patient's breathing 2 a minute, they have pinpoint pupils, and what do you think you're going to do for that respiratory acidosis? Give them Narcan. Give them flumazenol. You got to get them breathing again. What if it is a pneumonia? You may have to re-intubate them to keep them atelectasis. Get a chest X-ray. So you've got to treat the respiratory causes. What if they have all this crap in the back of their throat? Do what to it? Suction. Suck it out. The respiratory depression, like opiates, central nervous system injury, pulmonary diseases, pneumonias, emphysema, kidneys, they will compensate, but it takes a while. Respiratory, as the liver makes more, kidneys pee out less, We saw the attempt, I don't think it worked. 2 is not enough. And I swear I won't give you 4. It'll be 6 or greater or 2 or less. Will that make you happy?
Yeah, okay.
Correction of the pulmonary defect. Intubation is always, sometimes you have to re-intubate them. If they have ARDS, if they're getting steroids and re-intubate. If they can't move any oxygen, they're getting intubated. If their partial period oxygen is 60, they're getting intubated. Tracheobronchial hygiene. This could happen before the surgery too. Does anybody know the name of what the anesthesia won't do the case if they're having respiratory issues? So we do something called at the bottom right there. Pulmonary toilet. These are all things you can use for a patient to clear up their lungs so that anesthesia says, all right, I'll intubate them. Does anybody know the ABCs of anesthesia?
Circulation.
Wrong. It's airway, book, chair. They don't like getting involved. They will not do a case where they're at risk for their own, having to do something. So if you send them a patient that's having some respiratory issues, they're gonna cancel your case. And now you don't do the case and your surgeon loses money and you lose money. So pulmonary toilet clears them up so that the anesthesiologist doesn't panic and leave. So what does that include? Deep breathing. What can we give them? PAs can order this. Yeah, and especially if they're splinting after surgery, you treat the pain and you prevent atelectasis with this. It's called incentive spirometry. Treat the pain and give them incentive spirometry, make them use it. Coughing, humidified air. Oxygen, if they're on oxygen, oxygen is very dry. Humidify the air, they won't get as inflamed. Bronchodilators, open them up, incentive spirometry, prevent atelectasis. Chest PT. Get the respiratory, bang on their chest a little bit, break up some of those clogs. So pulmonary toilet prevents atelectasis, prevents pneumonias. You gotta have them breathe fluid that collects in the bases. They develop a pneumonia. It's the number 1 nosocomial killer of in-hospital patients. An ounce of prevention is worth a pound of cure. So again, suction as necessary. Position allows secretions to drain. All on us. Suctioning, chest PT, up the nose if you have to. If you need to get a bronchoscopy, that's pulmonary. We gotta order it. Incentive spirometry, pain. Don't let them splint themselves. You gotta breathe deeply. Coughing, bronchodilators is necessary. Albuterol, Atropine, dried secretions. Anesthesia will not do the case if there are issues. Because it panics them. Now they have to work. Case number 2. Who wants to do case number 2? Well, it's not so bad. Thank you. How about you? Want to do case number 2? What? Yeah, just read it. Not that bad. Good.
Your qualification for if you're anxious, is to the enough air, that's 4 days. Age of 7.47, CO2 of 90, CO2 of 38, 519,
All right. Do I care about the area yet? No. So which way is their pH going? If we start in the middle, spot. 4, what is she? So she's a whole close, only 1 off from 7.48. You agree? Which is like, should be 1 group of 10 less. You agree? 7.47 is only 1. But How many is she down? 140, the PCO2. How many groups of 10? One. And the pH is going up, and our PCO2 is going down. Any pulmonary toilet. So Megan, our pH is going up, and the pH is going down, and the pH is going down, sorry, and the PCO2 is going down in opposite directions. So with a 7.47, she's what condition? Alkali, CO2 going in the opposite direction. Yes, in metabolic, what's the problem? The bicarb and this pH going the what? Same. This is PCO2 going down, pH going up opposite direction. She's alkalotic. Who's it for? Not metabolic, kids, respiratory. Now, question. Right here, what's your name? Noel. I'm gonna switch from Megan to Noel. The bicarb dropped a little bit, right? Is there a formula for the expected attempted compensation?
No.
Yes, there is. Respiratory. Will the body say, stop making bicarb, pee out more? There's a formula for that. It's metabolic alkalosis. But before you even get there, it went down the CO2, how many groups? 10. And it went up, how many groups of 0.08?
Less than.
About the 0.0, one group. You agree?
Yes.
Did whatever compensation the body tried work? No, it's as bad as we expected.
Not 0.04.
Or less, so
Well,
7.4.
Yes.
So what is your overall, before you even get to the expected compensation, what is it? What kind?
Uncom.
There you go. Megan, that's an uncompensated respiratory alkalosis. So look at the bicarb. It's 19. What's normal? 22 to 26. In an acute, let's say that's less than 5 days, how much do I expect the bicarb to drop? 3 to 5. So let's use 5. 5 from 22 is what? 17. She's a 19. Can I make a case in court? That's the attempted compensation. Did it work?
No.
No. Try, didn't work, yes.
Chronic, like at this point, these days.
Yeah, I'm thinking about 5, 3 days is sort of the borderline. 5 or more, I'm thinking chronic. So. Guess what? They're acid alkalotic, right, Megan? But with a bicarb like that, will the right side of that be greater than 40? With a small bicarb of 19? That bicarb is only 19. If I use the metabolic alkalosis formula, this side only has a 19 here. Will it be greater than 40? No, the formula fails. So it's not a metabolic alkalosis, it's a what? Respiratory alkalosis. You're welcome to the formula.
If the pH had been 7.44, would you have considered that a full compensation?
Yes.
Okay.
That's 0.04.
I know, I wouldn't
But
do
it's in
that
the
to you
range.
either,
Okay.
but it's in the range, but if I want you to be fully compensated, I'm giving you a 7.4.
Okay.
But you have to know what it is.
Yeah.
I'm just giving you the numbers. So the formula failed. The compensation, I can make a case. And it went up for 10, 0.07, which is really close to 0.08. It didn't move the needle. It's an uncompensated respiratory alkalosis, which is much more common than you think in your surgical patients. All right, there is my expected compensation for an acute respiratory alkalosis. 3 to 5 for every 10. She had a 30. I'm expecting it to drop. It could be 5. 22 minus 5 is 17. She was a 19. Yes.
Isn't it chronic?
Now I would say 5 or more is more chronic. 3, I'm thinking acute still.
Okay, wait, so before you said 3 is chronic, and you said 1.
Nah, you know,
And this is.
Let's establish this. 'Cause
I'm not gonna give you a patient with that, but I'm thinking 3 days, I could still make the case as acute.
Okay, so,
I'm thinking of 5 days or more, I'm
This is
thinking
4
more
days.
chronic side.
okay,
This is
chronic
4
is
days.
5 days.
So I'm still thinking acute, I'm calling it acute.
Acute, less than 5. The recording is hearing this.
I'm
Less
calling
than
it acute, yes.
5. Less than 5.
You're in the air, 5 days Friday.
It's not,
What?
okay, there is no exact number. The truth is, it depends on what this particular patient's history is. So I know something that comes in for a very short term. Someone who's post-surgical, you have to use your brain sometime. They come out of surgery, they're anxious. They're hyperventilating because they're nervous. I know that patient didn't walk around 24 years being nervous for the surgery. It happened in this range. So if they're 4 days, 5 days, I will still call it acute because I know their history. They just came out of surgery, no one's coming to visit them, and they're upset and they're sundowning because they're elderly. I'm calling it acute. The next patient comes in that has been hospitalized 7 times for asthma. Now, I know this person has asthma for years, since a child. Whatever they have, I'm calling it chronic, regardless of the timing. My slide that says treat the patient first really comes into play here. So I apologize, I can't give you an actual 3, it's 4 days and 11 hours and 59 minutes. Phil said that's acute. Oh, you're 5 hours, you're chronic. They like 1 minute apart. It doesn't work like that. It's what you've got in front of you that matters.
So you'll be more specific than on the test, like with the.
I'm gonna give you some history.
Okay.
So you could say this patient they've had COPD for 20 years. And they're a smoker for 35 years. I know what I've got here.
Yeah.
So even if they're 4 minutes, 11 hours and 59 seconds, I would still call it chronic.
Okay, that's fair, and that cleared up the air, I think.
Does that change how you answer the question? It's acute or.
Only for the compensation pay. And in this case, with the 19, I could actually make a case for either acute or chronic. But that's the only difference. It's what you can make a case
So
for.
like we should know those specific numbers.
I'll give you this.
Oh, you're gonna give us this too?
So it's one.
Okay.
Oh my God.
You're on, yeah.
I didn't know that.
Did we just use yours, or do you want us to also use those?
That's just the expected compensation form. There's 2 different
No,
formulas.
we can use yours.
Did she like print it out?
Different.
Have it?
This is expected compensation of the bicarb. This is pH for
I
CO2
think so.
to tell you if this worked.
I just don't get why you.
Why do you need to know the expected?
Yeah, why do you need to, like, if you use your formula, you'll know.
Because if you didn't know what to expect and you saw a bicarb of 19, you might call it what? A low bicarb. You might call it a metabolic acidosis.
But I feel like the other numbers.
With the pH though, even.
Could be overcompensated. You're running into trouble. That's why you use these formulas to say, I can make a case for that bicarb level. It's not really a metabolic acidosis. It's just the attempted compensation. Then I apply this. Did it work? Did it work a little? Did it not work at all? I give it to you. But yes, you have to apply it. But I can't give you an exact number on chronic versus acute. That's one of those things where you're gonna have to use your own
Brain,
cognition, your own
the
what's
hamster
the word I'm
wheel, you
looking
know?
for? I can't think of it right now, but you're gonna have to make some of your own medical kind of decisions that aren't based on actual numbers, but some of your own thoughts of your brain.
Right, awesome.
All right, case 2. pH up, alkalosis, like Megan said, PCO2 down. So respiratory, opposite directions, alkalosis. And because she never had this before and is only experiencing it after surgery, I'm calling it acute. What the bicarb should be, I can make a case for 22. Again, There's that formula, it's on your exam, one group of 10 minus 5, 17. I would still say is an attempt at metabolic compensation. The hus was a 19. I can easily make that case. I don't know if it worked. I have to apply my formula, but I know the attempt was there. That's why I use those formulas. A Q, it should go down 3 to 5 for every 10. So a 19 is definitely higher than 17. That's an attempt. Now I use the 0.08 thing and I realize it didn't help. I don't care about the NI gap. Doesn't matter. The answer is no. So more common than we realize in surgical patients, a loss of CO2, increased alveolar ventilation, blowing it off too much, causes anxiety. They just got out of surgery. No one's visiting them. Pain. We set the vents that it's too quick. Maybe your vent, there's still intubations at 20, and they really should only be at 16. You're blowing off their CO2. They don't want to, you're doing it. Increased alveolar ventilation, anxiety, pain, assisted ventilation. We can make the vent setting less, but you got to recognize it. Encephalitis, because any infection of the brain causes Cushing's. And Cushing's, what is one of the components? You get a high blood pressure with a wide pulse pressure, a bradycardia, and essential neurogenic tachypnea, like a chain Stokes. Little periods of apnea and then periods of tachypnea. You can blow up your CO2. The liver will attempt to respond by making less bicarb. The kidneys will send out more. And you will see that on the bicarb level. And if you use the formula I give you, you can make a case that's expected. Signs and symptoms, like the hypocalcemia, tetany. Does anybody here ever hyperventilated?
Yeah.
Your fingers crimp up, you get ringing in your ears, you get a really bad headache. Treat the underlying cause. In the old day, you know how we used to treat that? Put a white paper bag over their face, but we can't do that anymore. Headache, tinnitus, carpal spasm, ringing in the ears. Dangers, again, it's harder to treat. You'll blow off CO2, your H pluses will drop, all your potassiums will go inside the cell because there's no bullies, and you will experience hypokalemia. And is hypokalemia as dangerous as hyperkalemia? Yes. The heart will fibrillate on you. And now, what is the vital signs of someone in ventricular fibrillation? 0, 0, 0, and 0. So you don't want that. And which of the two problems is easy to treat? The acidosis or the alkalosis? Yeah, alkalosis is hard to treat. Because you can't put a bag over the pain. Yeah, all right, you just got a surgery. Boop, look like a hefty bag, tighten it around here. Oh, I forgot. That would be bad. Correct any pre-existing hypokalemia, obviously, because it'll get a lot worse. Proper management of the vent. Don't let it fall below 30 on the PCO2. Again, watch for hyperkalemia afterwards, especially if you've added potassium. You may overshoot your mark. Because when you stop the alkalosis, some H pluses go back in the cell, some potassiums come out, and you've already added more. Make sure you check a potassium that you didn't overshoot your mark. Because is hypokalemia as dangerous as hyperkalemia?
Yes.
Yes. Here's number 3. Oh boy. Come on, let me have somebody. How about right there at the end? Yes. Read your patient. Yes, please. Always start with the patient.
You are going to see a patient who are when they have a history for uncontrolled non-diabetes.
Insulin dependent.
Insulin dependent diabetes, but the patient appears to be breathing fairly deep and rapidly. You being astute
Let's do it.
Okay, food surgical PA, yeah, and arterial blood gas, which reveals pH of 7.08, PCO2 of 14, HCO3 bicarb of 4, NRN gap of 22.
Okay, so question. Let's start with that pH. What are they?
No,
Question. I don't have a 0.08 for the metabolic side. There's no formula that I could give you like exact. However, using your brain, even if there was an attempted compensation at a 7.08, did it work? No. You need a formula to say 7.08 is in the basement of acidosis. No, you don't. You can use your brain. So whatever this is, can we call it uncompensated?
Yeah.
Now, how does which one is the most dramatically down? The CO2 or the bicarb? So whatever it is, it's a lack of bicarb on the metabolic side. So whatever this is, 7.08, it's a what acidosis? Uncompensated metabolic acidosis. Low bicarb, dramatic. That's the metabolic side. And they went in what direction? Same. pH went down, bicarb went down. But also the CO2 went in the same direction. But if it was a respiratory problem, which way did the pH and the CO2 go? And it didn't. The CO2 dropped 14. So if the CO2 and the pH go in the same direction, is it a respiratory case? So it's a metabolic acidosis with an attempt at what? How? What's that breathing pattern called? Well, Kussmaul's. Did that Kussmaul's respirations move the needle if it's at a 7.08? No. So what is your diagnosis for this patient? Uncompensated metabolic acidosis. What do you have to check next? Somebody said it. Check the anion gap, and I'm giving it to you. The anion gap is 22. What's normal? It's a positive gap. There is a gap. What mnemonic are you going to apply? What's the D of mud pilers? Diabetic ketoacidosis. You just saved your patient. So you're going to run fluid through them. You're going to get a potassium level. Because if that potassium is low, and you give them any more insulin, it's going to go right through the basement. I start giving potassium even when it's high because I know it's going to plummet. And then you start a what drip? Insulin? An insulin drip. 0.1 units per kilogram. And then every 2 hours, you're going to check the level of the glucose and the potassium. And the potassium was 6.9. Is that a real hyperkalemia or is it the acidosis? Could be the acidosis. Now it's a 5.9 after 2 hours. What are you going to give them? Don't wait for it to plummet. Start your potassium. It drives the nurses crazy. But you know where it's headed. Yes.
What would the pH look like if it was partially compensated? So I have,
Without a formula, 7.3.
it would be like on the cusp close to it. 'Cause you
Much
can't
closer.
compensate the metabolic.
I'm saying that without a formula, I could just recognize that a 0.08 is
But you
really
couldn't give us
stuff.
like a 7.2, because there's no formula you can use it metabolic.
Even 7.2.
Not
Remember, how much does the body like to be out of whack?
No.
None.
So you can give us like a close out of range.
If I gave you a 7.32,
Not with conversion.
then I would think about a problem. Yes.
So since it's DK and you're treating it with like the protocol for that, would you be wrong if you also did that a bicarb, because it's just the parameters for giving the bicarb?
Actually, bicarb, it does fit the parameters, but I'm going to treat the underlying problem
Okay.
first.
So you don't have to necessarily give.
No, the underlying problem
You can.
first is treat that,
Okay.
first get fluids through them, then treat the elevated sugar levels. and balance the potassium. The problem with giving bicarb, even though it meets the parameters using your brain, what does bicarb look like?
Oh, it's negative.
It'll eat up one other thing besides the H pluses. What else has a positive ion on it? React K positive, and it's already
That's in
gonna,
the
it's gonna make that plummet even worse. Remember, it doesn't know what you're treating, it's a cannon. If you don't want the potassium to plummet, the last thing you're gonna give them is bicarb. So, guess what? If you apply the formula. Here's what happens. It's less than 40. The formula, if you choose to use it, it works. 40 will be greater with a bicarb of whatever it was, 12. This whole number will be less than 40. The formula works for what? Metabolic acidosis. So you can use your intuition and my numbers, you can use the formula, they're on the exam. And the body did attempt to compensate by breathing faster, cruise miles, it just didn't move the needle, 7.08. It's an uncompensated metabolic positive gap acidosis. Who is the villain? What mnemonic? Mud pilots. What's the D? It is insulin dependent diabetic. DKA. So I don't apply these formulas in that instance because these are respiratory formulas. Case 3. pH down, acidosis. It's a low bicarb prominently, it's a metabolic acidosis. The formula will work. If you like, choose to use it, it's on your exam. Anion gap is high, mud pilots. Now look for the cause, what? I think it's on a separate page that Susanna gives you. I think that's what she likes to do. They might just give you a sheet of paper to have right by you with your exam. Retention of fixed acids, loss of bicarbonate. Pulmonary compensation includes moles. It just didn't work. And again, anion gap. Can't put it in the lab. It tells you who the villain is, and you treat the villain. Calculation help you point towards the cause. All right. If it is a loss of bicarb, you know the parameters. This is because the body's has no insulin. The cells are still making energy. It's just using as fat. Fat are long chains of carbons with hydrogen on them. The energy's in the bonds. It eats the bonds and off go the H pluses. And that's why you get diabetic keto. Those 3 glycerin molecules come off, acidosis. And it'll eat up your bicarb. And guess what other lab thing you might want to see on that? Because it's a real metabolic acidosis. It's at the end of your ABG. Didn't include it, but it should be there. The base excess was -6. It's a metabolic acidosis, like you said. Anion gap, cause, treat that cause. Diarrhea is hard update because you lose both bicarb and potassium in your food. So you lose bicarb, you become acidotic, but the anion gap doesn't change because you lose them both at equal proportion. There it is. Why do you keep slapping? What is this mud pilers indicate as a culprit for metabolic acidosis? Gap or no gap? Positive gap. Know this. This is a good slide to study. Mud pilers, of which DKA is right there, the D. Again, there are some things, yes. I will tell you the patient first. They came in, they went in their garage.
But if some of them.
No, it's gonna be a positive gap in the office.
Right. I don't really care about you. I still know it is.
I know, my vaccine.
All right. We'll start with this, well, next time we see, we'll start with this.
Feels like.
Thank you.
I think it's like. Yeah. I like the one thing. But I'm very in the pocket, right? Oh, I'm on the. Yeah.
One thing, we found them with a, like, a bottle, he got them before we.
Thank you. Start early. Yeah, I don't.
Really good.
Yeah. Thank you. Yeah.
I think I have, the time I lost on Friday is now Wednesday.
Yeah.
I had to give up some
Bye.
time to Dr. Emmett.
Thank you so much.
Am I your last class?
Yeah. Yeah.
I had till 6, right?
Yeah.